Good morning, students. How are you all? So I hope you are all fine. So in our last class we have discussed about the graphical representation of the distance, time and speed, that quantity. Okay. So in this class we are going to see that how to derive that equation of motion, that we are going to see in the by the graphical representation that we are going to see today. Okay, the first one. Today's session is the motion topic, equations of motion by graphical method, because in the last session we have seen that only that graph, okay, how to draw the graph of distance, time and the speed, time or velocity, time graph. So in this module we are going to see that how to derive the different equations. Okay, so the first one, as you know that the velocity time graph, right? This graph I already said, but anyway today I will say that this graph, in the x-axis I have taken time t, in the y-axis I have taken velocity. So I am plotting that velocity time graph. So this linear line represents that uniform acceleration, right? Okay, so today that the three equations we are going to see that the first equation, speed time relation. So for this I uploaded that video. Okay, so just see the video. So good morning, students. So today we are going to see that equations of motion by graph method, how to find the equations of motion. So there are three equations we are going to derive: v equal to u plus at, s equal to ut plus half at square, v square minus u square equal to 2as. These three equations we are going to derive by using that graph method. So before that, so first we are going to derive that v equal to u plus at, and before that you have to just revise the concept which I taught in our previous class, because from that only I am going to derive. So look at the graph of distance, time and speed, time, that graph which I explained in our earlier class. Just revise it one. Then after here, just look here. So you are going in a car 20 km per hour speed. Okay, from A to D you are going to reach. From A to B you are going 20 km per hour speed. Okay, and then you are accelerating your car uniformly accelerating your car. That means next 1 hour, the somewhat 30 km hour, then 60 km per hour, then 90 km per hour. So while you are going C to D, that time you are going in 90 km per hour speed. Okay, so initially A to B you are going 20 km per hour, and then you are increasing your speed 30, okay, 30 maybe 60, okay, you are taking 60, then after 90 km, finally you are going 90 km per hour while you are reaching that D point. So that time you are going 90 km per hour. So I already mentioned that what will be that acceleration. So acceleration equal to change in speed, right? Change in speed divided by how much time taken. Okay, so this is acceleration, change in speed or change in velocity. Okay, change in speed or change in velocity divided by time. For example here, okay, it will take completely, it will take from A to D or 4 hour, for example 4 hour totally A to D. Okay, so first one, acceleration, how to find what is the acceleration of this car. What is your final speed? 90 km per hour. Okay, 90 km per hour minus what is your initial speed? 20 km per hour. So 20 km per hour divided by how much time you have totally taken? 4 hours. So 4 hours. So this is the acceleration. Okay, if you subtract the value and divide it, means you will get some value, acceleration. Okay, so same way here I mentioned some value, 20 km per hour, 90 km per hour. I mentioned some value, right? Sir, without mentioning the value, for example here, the initial speed they didn't mention, okay, initial speed didn't mention, so I have taken u, so u is considered to be a initial velocity or initial speed. So from, this is point O, okay, from O, here point A I have taken, okay, so this is the origin, okay, so this is A, I mentioned A, so OA, that means that object is going or the vehicle is going with some speed, I don't know the speed, so here I mentioned u, u represent your initial speed. So and then accelerated uniformly, so uniformly means already you know linear line will be there, a slanting linear line will be there, okay. So next one, so while it will go from A to B, okay, now it is in B, so this is what uniformly accelerated motion, okay, uniformly accelerated motion, and this is what somewhat you represent initial speed, okay, initial speed or initial velocity, okay. So now I have to find the acceleration. So acceleration means what is the formula? Final speed minus initial speed divided by time, or change in speed with respect to time. So I have to find the acceleration. So how to find the acceleration? So for that I have to find the slope of this line. So how to find the slope of this line? So just from B, connect that perpendicular line which is joining at x-axis, okay, just connect it. Same way here, this one, okay, okay. Now from A to B it get accelerated uniformly, okay, so I want the acceleration value, A value I want. So how to find that A value? So just look at here, so this is initial speed u, from O to A this is represent initial speed. So from B, here I have mentioned, see here, so here C, I mentioned this C, so from BC your final speed V, okay. So I want from this A to B only, okay, from A to B, from A to B what will be your acceleration. So how to find from A to B, what will be your acceleration, how to find means, so initial speed, total speed. So we have to find the slope of this line. So slope of this line, for the slope of this line, just we have to put one horizontal line, okay, here. Horizontal line here. So this totally represent V, okay, this totally represent V, and I want this line only, not from here. The totally I don't want this kind, this much. So I want this line slope only. This line slope means it is nothing but, see here. So from here it gets slanted manner, okay. So what will be your y distance, this distance, and what will be your x distance. So this distance here I mentioned d, okay. So I want BD alone. So I want BD alone. So total length BC equal to V, okay. So total length BC equal to V, and what is that? OA, what is the OA value? U. So OA value U, this is the rectangle, so opposite sides are equal, no. So OA value U means what will be this value? CD, so CD value U. So CD value also U, CD which is equal to U. So now if I want to find that value of BD, I want to find the value of BD. So BD equal to, what is the value BD? So BD which represent, see here, BD, this value I want, I know this value and I know this value, that means what is it, how to find? So BD means BC minus, what is this value? Here, CD, okay. So CD, okay. So BC, from B to C, what is the value? V, okay. Then C to D, what is the value? U. So V minus U, okay. So this BD represent, what is that value? BD equal to V minus U, okay. Next here x1, I want this x also, y value we found, I want x value also. So A to D, okay, A to D I want the value. So A to D represent means O to C. So OC and AD will be equal, right? Okay. So OC, what I have taken? Time. So here time represent t. Okay, from 0, this is the 0 value, this is t. So 0 to t. So totally this value. So this value represent t. Okay. Totally this one, this value to this value, totally this value. Okay. T. So this is t means this also t. So the x value from A to D is AD OC, which is equal to t. Okay. So we have to find the acceleration. So acceleration equal to, what is the formula? So acceleration equal to final speed minus initial speed divided by time. Okay. So here we are not going from the formula, from the line, uniform line, we have to find the slope. So slope of the line. So slope of line AB, which is equal to y2, that means this value. So this value what we found? This value BD. So BD means what? V minus U divided by A to D. Okay, this value x value, AD value t. Okay, so slope of this line represent acceleration. So A equal to V minus U divided by t. Okay, so A equal to V minus U divided by t. Okay, here I will write. So A equal to V minus U divided by t. So from here I will take this t value here. So what will happen? So V minus U, this will go that side, means A into t, right? So A into t, AT. Okay, so V minus U equal to AT, and V equal to this minus U will go that side. So what will happen? Plus U will come. Okay, so AT